One being how you factor trinomials, so 3 terms. And with this works really well if we have something in this format, x squared plus bx plus c, where the a value this is actually a, is 1. So if the a value is 1, this rule will work. And we're going to use this. We're looking for 2 numbers that multiply to be c. And of those 2 numbers, they also have to add to be d. So it's kind of like a puzzle. You have to think about what 2 numbers could multiply to be c and then add to be d. So let's start with number 1. It has to multiply to be 12. So let's list out the factors of 12. What times what will give us 12? 6 and 2. 3. 1 and 4. Always remember the 1 and whatever because that might be your answer. Then of those factors, which pair, if I added them or subtracted them together, would give me 7? 4 and 3. So we're going to make 2 sets of parentheses. Whatever the variable is going to be just x first in both. Kind of like your difference of squares. But then the 2 numbers you found, if they're positive, you put plus, and then whatever the number, and then the same thing in the other one. So x plus 4, x plus 3. If I were to multiply this back out, x times x is x squared, 3x, 4x, 12, and if I add 4x and 3x, I get 7. So that would work. Use the distributive box method, FOIL method to check yourself. What questions do we have so far? Right, let's do number 2. 2 numbers that multiply to be 20, but add to be 9. So what are some factors of 20? 10, 5 and 4, 1 and 20, and that's it. So of those numbers, which ones would add to be 9? 5 and 4. When we write those 2 factors, our variable now is n, but we're using 5 and 4, so plus 5 and plus 4. It doesn't matter which factor is which, you just have to put it in both. Let's do 5 and then we'll jump to a different kind. So in 5, what are your factors of 5? 5, and that's it, it's 5. A lot of the times when these 2 numbers are like 1 away, 1 is going to be one of your answers. So then how would we write those 2 factors? K plus 1, K plus 5, or K plus 5, K plus 1, doesn't matter. So all of those examples were a plus and a plus. Now we're going to do some examples where there are negatives or minuses somewhere in there. So let's try 7. The process is the same. Ignore the negative for a second. Think about your factors of 18. What times what would give us 18? 9 times 2, 6 and 3. 1 and 18. Now, because it's a negative 18, one of these numbers is going to have to be negative when we add or subtract them together to get positive 3. Which one would do that? Which pair would do that? 6 and 3. Which one would be the negative? The negative 6 plus 3 would give us positive 3. Negative 3. So then in your factors, we have n plus 6 and n minus 3. And if we were to distribute that out, we'd have n squared minus 3n plus 6n minus 18, and that would give us the 3n. So if you would like to remember this by rules, if you have two pluses, you're gonna have two pluses in your factors. If you have a minus at the last term, one of your factors is gonna be negative, and the smaller one is gonna be negative.
So should we like n times negative 3, it's not gonna be negative 2.
Remember that there are 4 terms and you have to combine them.
Oh,
Right, let's do number 10. Factors of 54. You may have to use your calculator if you don't know all of those factors. If you're not sure, start dividing by 1, by 2, by 3, by 4. Keep going until the numbers either get closer together or they're the same. Six times 9, 3 times. Times 18. Okay. 1 times 50 over. Does 4 work? Sometimes it's a guessing game if you're not sure. You just type it in the calculator, see if you get a whole number. And then when you look at 6 and 9, those are probably the last ones because 7's not gonna work and 8's not gonna work, and then the highest was 9. So you would stop there. So then of those, we have to make one of them negative. Which pair could we make one of them negative to add or subtract to be positive 3? 6 and 9, which one would be the negative? So then the two factors will look like what? S minus 6 and S plus 9. There are 2 more types. Are there any others that we want to see go over with the 2 pluses? So 3, 4, 6, 8, or the one with the negative at the end, 9 through 14.
So what if we can't divide that number by?
So regardless, it always has itself in one, if nothing else. Okay, so let's look at we'll look at these and then there's one other example. So skip down to 15, where we have 2 negatives. Again, the process looks the same. We're looking for factors of 63, 6 and 9, 7 and 9, 1 and 63. What was that last one? 3 and 21. I'll scroll it right now. 2 wouldn't work. Don't think 4 works, 5 wouldn't work. Don't think 6 works, and then we have 7, 8 would work, so I think that's it. So then of those 2, again, we have a negative 63. One of the factors has to be negative. Which pair could we choose and which one would be negative? 7 and 9, that pair, and then
Why that?
if I were to add or subtract these 2, would we get negative 2? What about this one? So it has to be this one. But would negative 7 plus 9 give us negative 2? Negative 7 plus 9? No, it wouldn't. Have equal positive. So how do we make it negative? Make the 9 negative. So in this case, when you have 2 negatives, the bigger number is gonna be the negative. One is still going to be negative, but when you have two negatives, the bigger number is going to be. Let's try 16. Factors of 3. 1 and 3. And that's it. So which of those numbers would be the negative to make this -2? 3. So then those two factors would look like what?
Plus 1 and a minus.
A plus 1, a minus 3, correct. Do we want to see 17 or 18 before we do a couple on the back? Sure. So for 18, we're looking for factors of 72. 9 and 8, 1 and 72. Keep dividing. 72 by 2, by 3, by 4, by 5, keep going. 3 and 24. Is that what that was? 3 and 24. 6 and what? 1, 2, 3. Does 4 work? 4 and 18. 5 wouldn't work. We have 6. Nothing 7 works, and then 8, 9. So that would be all of them. I like to go in order, so I know I'm getting all the numbers. Start with 1, go to 2, 3, 4, 5, 6, 7, 8. All right, so of these two, which pair would we use to get -14?
4 and 18.
4 and 18 with negative. 18. So our two factors, x plus 4, and x minus 18. Last time, on the back, I believe, of that sheet, there are something that we didn't do before where we have a minus first and a plus second. So look at number 10. So again, same rules apply. Factors of 40. 4 and 10. 5 and 8. 1 and 40. 20 and 2. 3 won't work. We have 4, we have 5. What? I don't think 6 works or 7. I think that's it. And then if we are multiplying two numbers to get 40, how could we add to get -14? Say that one more time. Yes. So remember that there are two ways to get a positive. Both of them could be positive or both could be negative. So if we make them both negative, that would work. Positive number for this, yes, but when we subtract them. So for this one, if you have a minus and a plus, both of them are going to be. Let's do. There are not many of these. Let's do another one. Number 12, factors of 36. 36. 36. What else? 9, 4, 12, 18. So of those, which ones could we multiply to get 36, but add to get -12. 6 and 6, if they're both negative. So what would those two factors look like? Because these are the exact same thing, if you wanted to write this as w minus 6 squared, that would also be okay. As you're working through these problems, be careful because sometimes it looks like these will be the two numbers, but when you actually add them or subtract them together, they don't actually end up being the number. So be careful with that. This is part of a delta math that will be due. For you guys, it might be this week, it might be next, I have to double check the dates. But we're gonna continue this and the rest of those notes to one, so don't lose these. You guys can put calculators up.